Hello and a very warm welcome to the Mercedes factory here in Brackley. Today we're going to be taking you behind the scenes to get up a little bit more close and personal with what goes on and how we design, develop and manufacture our Formula One cars. We're actually started here in reception, but my colleagues and I will be taking you around the rest of the factory. Let's have a little bit of a closer look. Just over here, we have our very own piece of motorsport history. This is the W10 EQ Power Plus. This was the car that Lewis Hamilton was driving when he crossed the line in the final race of 2019 in Abu Dhabi, helping him, of course, to his 6th Drivers' Championship and helping us to our 6th Constructors' Championship. We've left it exactly the way it was when it crossed that line. As we come round over here, we're very fortunate enough to be able to display some of the other trophies we've got over the last few years and our successes, including, of course, the Drivers' Championship and the Constructors' Championship.
Welcome to the inner heart of the Mercedes factory, and it really is the factory that never sleeps. 24 hours a day, 7 days a week, there are engineers and technicians here building our Mercedes Formula One cars. And 80% of the car is made out of carbon fibre. We use 50 different types of carbon fibre in the component and depending on what it is on the car that we're building. This is a very complex process and the technicians have to lay this up in moulds and glue different layers of carbon fibre together to form the finished article. But once it's been built, we have to inspect it to make sure it's to standard of the highest quality. And that's the job of inspection and also NDT, non-destructive testing. We use various methods to do this, including CT scans, ultrasound, and even X-ray to look at the inner parts of the layers of carbon fibre to make sure the part is ready.
I'm down here in the machine shop where 50 skilled engineers and apprentices manufacture approximately 30,000 components a year. Wheel axles, uprights, gearbox casings, just to name a few. And it's all made from aerospace quality material: steel, aluminium, titanium. We have 24 of these large industrial milling machines, 11 of which are 5-axis milling machines. But we also do manual machining, grinding, fabrication, welding, and electrical discharge machining. We work to an incredible degree of accuracy. We call it a sub-10 micron tolerance level. Now, 1 micron is 1,000th of a millimeter, and your average human hair is 70 microns. So that'll give you some idea of the degree of accuracy we have to be able to compete at this level in Formula One.
We're here in the test and development department, or as we affectionately call it, the make it or break it department. And it's where all the individual components that we've manufactured get to be tested, both for reliability, durability, safety, and we also look at the setup of the car. And that's what this rig behind me is for. It's called a 7-post rig. 4, 1 on each wheel, pushing up against the car to simulate the track that the car will be on and any curb strikes as it goes around the corner. And then 3 posts that pull down on the car to simulate the downforce levels that it will be experiencing at any given circuit around the world. We use historical data to correlate this with our simulator to make sure it's accurate. Ultimately, all of these machines behind me are testing these components, sometimes to destruction, to make sure they're safe, but also they perform at peak performance.
Here, in a much more serene environment, we have our IT department. 54 permanent staff operate within about 30 different roles to look after 1,800 PCs, 500 phones, as well as all of our Epson printers, our TVs, meeting rooms, and of course the equipment in the data centers, as well as the traveling equipment that goes away with the race team and operates in the garage. Now, to work here, you need a broad skill set and be of high agility because we're dealing with over 300 different applications every single day with software upgrades and hardware upgrades frequently. For example, our laptops get upgraded every 3 years. So a lot of pressure on a small team for our 1,000 staff.
I'm here in the paint shop where all the bodywork, hospitality, branding and artwork gets carried out for the team. In this department, we have 20 staff that work across paint, graphics, and airbrushing to make sure the car looks absolutely perfect every time it goes out on track. The most complex component to paint is the front wing. It'll take about 30 hours of labor to complete, and we like to turn around everything in one day if we can. So oftentimes we'll have several technicians working on the same part at the same time. A chassis will take between 22 and 24 hours, and a front nose will take about 8 or 9 hours. We're also very lucky here at Brackley. We're the only people outside of Stuttgart that are allowed to paint the famous three-pointed star. It takes 27 processes, and it's made up of 4 colors: black, blue, brown, and white. It used to take us 2 hours, but we've innovated, and now we can get it done in 30 minutes.
Welcome to the RSR, or Race Support Room. Now, this bespoke facility is crucial to our success on a race weekend, and it's made up of about 30 engineers that are supporting us to analyse all the data that's coming off the car. About 30,000 channels of data, in fact, from over 400 sensors on the car. Impressive stuff. And these engineers are made up of tyre engineers, aerodynamicists, of course, data support. And this can be a key performance differentiator between us and our competitors. We're also listening in to all the strategic decisions that are made by other teams, so that can help us gain a competitive advantage over the course of a race distance.
Hello and welcome to the simulator department here at the factory. We're actually in the simulator control room at the moment. It's all bespoke to Mercedes. It's designed and developed in-house, but we actually use a commercially available graphics package. We want to make it as accurate as possible. So we have the chassis, the cockpit, the halo, the seating position, and the pedals exactly as they would be out in the real world, so the drivers can get a real feel for how it's going to be. But it's also so we can get information to develop the car going forward. We can change different variables to do with the weather. We can change the suspension setups, the aerodynamics, the powertrain. It's been really valuable when we've had such a mixed up calendar. We've had tracks come back on that we've not driven at for ages, and we've had brand new tracks that we've never been to. So we've been able to load them into the system, allow the drivers to get familiar with the new circuits, but also test the setup to give us the best chance on a Sunday afternoon.